So I called this applications of vectors, and underneath here I wrote the famous river question. It says, an observer is standing on the shore of a river. He sees a boat traveling across the river. The boat's velocity on the river with respect to the shore, this is what the observer sees, is 8 meters per second at an angle of 65 degrees with the shore. Say, what? What does DULP stand for? Come on, people. What has DULP stood for all year? Draw a little picture. Let's draw a little picture. They didn't say which way the river is supposed to go, but I noticed since I have a nice horizontal section, I'm going to say, okay, well, first of all, I got to do this and that. I'm going to say, okay, I'll go blue. Here's my river. There's one side. There's the other side. And although they didn't tell me, let's let the current go to the right in the positive direction that we're kind of used to. So I'm also going to draw a little arrow right here, and I'm going to say, there's the current. And what we're imagining, TJ, is this. The boat is pointing straight up with its motor, but which way is the current pushing it? So the person on shore sees it traveling like that. How fast? 8 meters per second. What angle? 65 degrees. Let's write that in here. Let's draw that. So here's what the person on the shore sees. 8 meters per second at an angle of 65 degrees with the shore. Oh, and I know the current pushes it to the right, which is how I know that the vector points to the right, not to the left. But Jamie, here's my argument. That's made up, that vector that you see is made up of two components, of two velocities. It's made up of a current pushing it to the right and a boat motor pushing it straight up. I'm going to argue that we can actually think of this as a horizontal and a vertical velocity happening at the same time. In fact, we gave those a name. Last class, we called them something that began with the letter C and rhymed with components. That's what's really happening. You don't see that, and I'm assuming all of you have looked and seen a boat on a river at least once. You live near the Fraser, for Pete's sakes. You don't see that the boat is traveling with two different velocities. Your brain just sees the one at an angle. But I'm going to tell you mathematically, in terms of physics, Abe, same thing. Why is that so handy? Abe, what's part A asking me to find? Hey, what's the current speed? Which of those represents the speed of the current? Vx. So I have a lovely right angle here. I'm going to make a little note here, Vx exclamation mark, and I'm going to get triggy with it. Let's do some trig. This 8 hypotenuse, yes? What's Vx opposite or adjacent? Which trig function can I use to find Vx? What always goes next to the trig function? The angle. What's the angle here? 65. If it's a theta, then you know you're going to be going inverse cos or inverse, but we're not going to be here. And it's going to be adjacent over hypotenuse. How would I get Vx by itself? Okay. Vx, the current, is going to be 8 cos 65. How fast is the current moving? By the way, I like this question, I like this question, I like this question, I like this question. You're going to get a river question in the future. It's a nice application, and I like it, Kayvon, because it's a little easier to visualize. By the way, this is the same as an airplane with a crosswind, but for some reason I find the kids find the river with the boat easier to visualize. I don't know why, but okay. Maybe it's because you live near the Fraser. What'd you get?
3.4 meters.
Give it to me to 2 decimal places.
3.38.
And what's after the 8?
1.
1. Because I'm going to be using this to find other stuff. So I'll go 3.38. Is that all right, Roy? Roy, what's B asking me to find? Which of those velocities is how fast the boat is moving across the river? Vy, not the 8. In fact, you know what? We're never going to use that 8 again. We're only going to use that 8 to break it, the angled one, to break it up into its components. And then for the rest of this question, we're going to deal with either vertical or horizontal. So you're telling me that this here is... Now that's, TJ, if I draw the river horizontal, because that's what they gave me. If they give you a vertical river, then Vx would be across the river, and Vy would be your current. But they gave us a horizontal. We drew a horizontal river. Vy, opposite or adjacent? Which trig function? I could using Vx, but since I found Vx, I'm worried it might be wrong. I want to use that 8 because that they gave me. I know that's right. Which trig function? Sine. In fact, Nick, I think you'll notice it's going to be almost identical to what we've just done. Vy is going to be 8 sine 65, which, if you have a good calculator, means you might be able to just backspace and edit, which would be convenient. What is 8 sine 65? To 2 decimal places as well.
7.25.
7.25? Is that rounded off properly? Yeah? By the way, as a quick check, if I go 7.25 squared plus 3.38 squared, if I go Pythagoras, I should get 8. Did I? Chris, close enough that, you know what? I now am pretty convinced that I did find Vx right. That can't be a fluke. Quick way to check your answer if you have time on your test. Okay. So, yes, Amanda, this person is traveling at 8 meters per second at an angle of 65 degrees with respect to the shore, or they're traveling 3.38 meters per second to the right and how about east, and 7.25 meters per second north. Same thing at the same time. Joel, my birthday boy, can you read C to me, please?
The river is 256 meters wide.
Stop. Let's go label that. Oh, you know where that is? That would go... like that, yes? Yes? Keep reading.
The river is 256 meters wide. How long does it take to cross the river?
What are they asking me to find here? By the way, you may wish to get out your formula sheet, although you may have some of these memorized. The other reason I like this lesson, we're going to be doing great review as we're getting close to our final exam. Because if I heard you all correctly, you said we're finding t equals question mark. What else do I know? We're going to defic a little bit here. What? Now, we are going to assume that when you're on a river, you're not gunning it and slowing down, gunning it and slowing down. And we're going to assume, well, I've watched rivers. Rivers don't speed up and slow down. They go at a fairly constant speed. So acceleration is 0. That's not enough. I need one more thing. I need a v. Which velocity? Careful. Now, let's look at our picture. Nick, my friend, what direction is the distance that they gave me? See it? Use the velocity that's in line with that, because we're in vector land. Direction matters. Don't ever be using the slanty 8, because that's not in line with anything. If I think I want to use the velocity that's in line with my distance, and I've done a good diet, this is why I dopped, by the way, drill a picture. Can you see which one is screaming out to, which velocity do we want to use? Vy. And you said we needed V initial. Nick, you are correct, but since A is 0, V initial is V final, is V average, is Vy. So I'm just going to write Vy equals, and I got it here, 7.25. I'm looking for an equation that has T, D, A, and V in it. Hey, this is great review for this is from October. But you're going to see this in about, I think we only have 15 more classes, I counted. Which one? Which equation? Or D equals VIT plus a half A. The most useful of the equations. It's a quadratic, so it's a bit yucky. We're going to use D equals VIT plus a half AT squared. Although Amanda, actually, why can I do that? A is 0, which turns this into the crappy one we give you in Science 10, the boring one. D equals VT. Joel, what did they tell us? What did you say they were asking us to find? What? How would I get the T by itself? TJ, divide by what? I want to get the T by itself, so I want to leave it. So I want to get rid of the V in front of you. Divide by the V, right? So TJ, if I hear you correctly, and I think I do, you're saying T equals distance divided by V. And again, the key idea on the river question, and Nick, I'm glad that you said the 8 at one point. You better make sure if you're using a vertical distance, you better use a vertical velocity. If you're using a horizontal distance, you better be using a horizontal velocity. In fact, once we use the 8 to find the components, and we never use it again. It's much easier to think of stuff moving left, right, and up, down than slanty, yucky. Distance, 256 times 7.25. Right? I said time. I should have said velocity, 7.25. Yes, we're dividing. You heard me say times. I was looking at the T for some dumb reason and said time. Yeah, I never make mistakes. Do you get 35.3? Now, if I really wanted to be uber accurate, I could even go like this. 256 divided by bracket 8 sine 65, because that's almost the same amount of typing as typing 7.25. To type 7.25, that's 1, 2, 3, 4 keystrokes. To type 8 sine 65 is 1, 2, 3, 4 keystrokes, whichever. Still 35.3, 35.31. I'll go 35.3 seconds. That's how long it will take this person to cross the river. D. Cole, what's D asking me to find? You're the only one here this time.
How far down the bank will the boat have moved when it reaches the other side?
So what's it asking me to find here? Oh, and I know we said that for the river question, we're going to assume A is 0. By the way, we don't need to. In Physics 12, we will deal with accelerations that are vectors up, down, and left, right, but not here. We did do one like that a couple of days ago in the lesson. What else do I know? By the way, let's go back and look at our diagram. I think what we're talking about is this. You're starting right here. You're drifting, you're drifting, you're drifting, you're drifting, you're drifting. We want to find that D right there. Is that a vertical or a horizontal distance? Based on how I've drawn it.
Horizontal?
Hey, Cliff, take a guess. Which velocity do you think I'm going to use for this question?
Vx.
The current, okay? So I'm going to need Vx. I scrolled down. What was Vx? Was it 3 point something? 3.38. Thank you. That's still not enough to find D. I need one more thing. What? Time. Wait. What did we just figure out in part C? And isn't the time to get across going to be the same time as you drift down sideways? I think exactly. Because once you hit the far shore, would you not stop drifting down sideways? T from part C was 35.3. Which equation am I going to use? Amanda? Nope. Same one as before. D T. Oh, I'm sorry, you didn't say the D equals. Yeah, okay. D equals VIT plus a half AT. Oh, but what's A? So the half AT squared is going to, do you mind, just to save our room, because I didn't give you much room, I'm just going to say dx equals VXT. Yeah, plus a half AT, whatever. Cole, what are they asking me to find here? Oh, and I already got the D by itself. This is going to be straight plug and chug. VX 3.38, T 35.3. How far down? You get 119.3? Chris says yes. Meters. Chris, can you read E to me, my friend? What is the boat's engine velocity? This is a trick question. It's so easy that it's tough. Let's go back to my picture. What is the boat's engine velocity? I'm going to give you a hint. Wouldn't be 8 meters per second because that 8 includes the current, does it not? Jacob, Vy, what's pushing it? What's pushing the boat across the river, Nick? The engine. Where is the velocity across the river? Vy. So for part E, what I want you just to, so that we know what we did, hey, V engine equals Vy. 7 point, was it 7.25? Yeah. And Nick, again, a lot of kids will go, oh, it's 8, isn't it? No. Can't possibly be 8 because some of that velocity is coming from the current. Also, that 8 isn't even in the same direction as the engine is pointing. The engine is pointing straight up. For now. So what's the boat's engine velocity? 7.25. What if you want to go, same engine, so you're going to rev the motor exactly the same way, 7.25, but instead of ending up 119 meters downriver, what if you want to end up directly across from where you started? How can you do that? Sean, what we're going to do is we're going to point our boat to the left. We're going to point the boat into the current, and if I do it just right, even though it looks like I should be traveling sideways, I'll go straight across. Can you imagine that? What angle? And how fast will you be traveling straight across? That's what this next question is asking. So F says, suppose you want the boat to land directly across from its starting point. I probably do. By the way, this is much more useful for pilots because pilots, they want to fly directly to their city. They don't, if there's a crosswind and the city's right there, want to end up way over here and then have to fly directly into the wind to get to where they want to point their plane into the wind. So even if you're looking on the ground and it looks like they're flying kind of slanty, they don't care. They want to go straight to their destination. Here's my thinking. The engine plus the current gives me my relative velocity. Right? You've pointed that out a few times. You said that 8 comes from 2 velocities. And we've just visualized, we know what the engine is going to look like. We're going to point it, Nick, that way. So I'm going to draw a little picture here. It's going to be that way. How fast? 7.25. What angle? Don't know yet. Plus, what does the current look like as a vector? What does the current look like as a vector? Sean says, I think you mean horizontal line pointing to the right. Yes? And I can even tell you how long that is. What was the current's velocity? It was 3 something. Abe? 3.38? The answer that we're looking for is adding those two vectors together. How do we add two vectors together, one wonders? How does one respond? How do we add two vectors together? Draw them tip to tail. Put your pencils down. Watch. I'm going to draw the first guy, 7.25, and then I'm going to start to draw the current. But look, watch. Look up. Look up. There we go. I know not to go that far. How come? Because I know what the resultant is supposed to look like. Which way do we want the boat to actually go? Straight up. I know not to draw the current this short, because that's also not going to give me a resultant straight up. If I know what my resultant looks like, it's supposed to be straight up. Tell me when to stop drawing. I'm going to keep going. Tell me when to stop. Right there. That's going to be the 3.38. And now you can pick up your pencils. Here is going to be our triangle. Stefan, you see how we put that together? Because I knew what the answer was supposed to be. Straight up, I drew the slanty one first. By the way, if you're ever doing a situation like that, always draw the toughest vector first, the slanty one. Then draw the easiest one, and almost always you're able to figure out, because you know what the answer is supposed to look like, how far to stop that easiest vector, when to stop that easiest vector. They asked me 2 questions. What direction and what will the resultant vertical velocity be? Let's get the resultant vertical velocity first. That's going to be Pythagoras. It's going to be resultant squared plus 3.38 squared equals 7.25 squared. Because this time we're not finding a hypotenuse. Right, Cliff? We're finding a side. How would I get the VR squared by itself, Brad, my friend? Minus 3.38 squared, and then how to get rid of a squared? So I'm going to do that all on my calculator, if you're okay with that. I'm going to go 7.25 squared minus 3.38 squared equals square root. What's your resultant velocity? $6.41. Pythagoras here? Well, how do I get the VR by itself? Minus that to that side, and then square root, because it's VR squared. How to get rid of a squared? Square root. Is that okay? I didn't show all my Pythagoras work because I didn't leave you much room. That's the second part, the last part of the question. It says, find the resultant vertical velocity. You're going to be going 6.41 meters per second straight up. In fact, since I know the distance is 256 meters, I could even find how long this will take you. I didn't ask that, but I could. But what do they want me to find? What's the first thing they want me to find? What? What's the first thing they wanted me to find? Second sentence, second word. Direction. Relative to what? No, relative to the shore. Here's the shore. This is the angle that they want me to find. Problem. That angle ain't in my triangle. Is it? Any thoughts? Jamie, was that a hand up or just a twitch? Yep.
You can find the angle inside the triangle and subtract it from the angle 98.
Okay. Put your pencils down. Look up. Jamie has given us a very good, but not quite really good suggestion, because I'm going to go one better on him. Okay? Don't write this down. I'm really going to muck up this diagram. Jamie said, hey, Mr. Dueck, let's suppose that this was 60 degrees. How big is this angle, Jamie?
30,
Why?
because it combines.
Okay. So, Jamie, you said if I find this angle, 90 minus, and I agree with that. What's this angle up here?
95.
What's this angle up here then?
That angle?
Yeah, I heard someone say it. Yeah.
What's the angle of the six? That's
Also 60? Okay, let's try it with different numbers. What if instead of a 60, and a 60, what if that was 70 degrees? How big is this angle?
20.
20? How big is this angle up here?
70.
Are you saying that this angle and this angle are the same one, which would even be faster than having to do your subtraction trick?
What's the Z angle?
Ah, it's Z angles if you've seen them in math. Alternate interior angles. They don't do much geometry in the new curriculum, but it's useful in physics. So although I was okay with Jamie's initial suggestion, I'm going to say, you know what? That's theta, and why not do it all in one fell swoop? Yes? I'm lazy. Why not? And I think that was a reasonable jump to make, yes? Oh, but if you forget, if you don't remember that those two angles are the same, Joel, did you follow Jamie's argument about how those two bottom ones add to 90? So I'll just find the slanty side one and minus 90? Nod your head. Let's see here. Adjacent. What's that 7.25? Opposite or hypotenuse? Hypotenuse. Up until now, every time I've asked you to find an angle, it's been tangent. Which trig function am I going to use this time to find an angle? Not tangent. Cos. That's why I said to you, someone asked, is it always tangent? I said, almost always. You know when it won't be tangent? When you know the hypotenuse and you were finding a slanty side. That also means because you know the hypotenuse, you're not going to be using tangent. For what it's worth. You say cosine? Mystery angle equals 3.38 over 7.25. What angle does this person have to point at? I'm going to guess close to 60-ish, somewhere in there.
62.2.
So let's go 62.2. Anybody else? Let's go 62 degrees. Relative to the shore. That is a much more challenging question. I do like that question. I do like that question. I do like that question. But I won't make that worth like 5 marks or 4 marks. That's a tougher question. A, B, C, D, and E, totally fair game to me. In fact, oh, handy hint. Nick, my friend, if they give you or you're asked to find a vertical distance, you better find or use a vertical velocity to find t. And if they give you or you're asked to find a horizontal distance, you better use a horizontal velocity. Why didn't I worry about finding a horizontal time? Time, vector or scalar? Scalar, I don't care about direction there. But velocity and displacement, vector, direction, 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 direction. Direction. Direction! Turn the page. Example 2, same question, different numbers. Oh, and a few other twists along the way. So an observer is standing on the shore of a river. He sees a boat traveling across the river. The boat's velocity on the river is 12 meters per second and an angle of 55 degrees with respect to the shore. Gulp. River. Let's let the current go this way. Instead of writing velocity of the current, can I write VC? Is that okay? And it looks like the boat is it's being pushed sideways. It says it's being pushed sideways at 12 meters per second at an angle of 55 degrees with respect to the shore.
The exact same question, just different numbers.
Do you ever have deja vu? Did I say about 30 seconds ago, same question with different numbers? I did? Wow. That's classic. This is my internet lesson. It's reserved for online posterity. Nick. Here we go. What's A ask me to find, Nick, my friend?
Correct.
Can't. Not yet. Oh, you know what I need to do? I need to take this 12 and never use it again, but the only way I can take this slanty 12 and never use it again is to break it up into what? Word that begins with letter C and rhymes with components. Components, which ones? Vertical and horizontal. So, I usually change colors for this to make it stand out. I'm going to break this up into Vx, which happens to be the current in this question, and Vy, which happens to be something else. So on your own, see if you can find the answer to A, the answer to B, the answer to C, and the answer to D. I will do them slowly up here. Let's see if we end up in the same place. Try E and F. Terrible drawing. I think it's going to be slantier than that. cosine. If you want to try the next couple of questions, there's my answer for E 9.83. There's my answer for F. Is that okay? Pause for a second. The lawnmower question is the next one we're going to look at. Lawnmowers. Why do we call them the lawnmower question? That's when if you've all pushed on a lawnmower, you're pushing down at an angle, but the direction of motion is horizontal. The acceleration is horizontal, even though the force is angled. Or in this case, instead of pushing down on an angle, we're pulling up at an angle. And this is a great review of forces. So it says this: a 55 Newton force is applied at an angle on the block below as shown. Okay? If the coefficient of friction is 0.21, and then it wants me to find a bunch of stuff. This is a force question. How am I going to start out? What's the first thing I'm going to do? Free body diagram. Let's label our forces. Get the obvious one. Good old mg down. Is this sinking into the ground like quicksand? No. Is this lifting into the air like Superman? No. But here's the key. Is the normal force here equal to mg?
No.
No, it's not. Now, how come? Before we draw the normal force, see that slanty force, the one that I don't like because it's slanty? We're not going to deal with it. The same way as when you gave me the slanty vector for the river, what did I do? Broke it into what? Begins with letter C, rhymes with opponents. I'm going to break this 21 degree, the force itself was 55, but I'm going to break that up into, I'll call it Fx and Fy. And Roy, which way is Fy pointing? Two-letter word that begins with the letter U. Which way is Fy pointing? A two-letter word that begins with the letter U and ends in the letter P. Up? Up. Now here's what that means then. You have gravity down, and normally, normal force, no pun intended, needs to cancel out all of gravity. But this vertical section here is canceling out part of gravity, so the normal force is bigger or smaller than gravity? It doesn't have to be as big, it's smaller. So I'm going to draw on my diagram here a really exaggerated little tiny Fn just to make it stand out. Any other forces? Friction. So when I'm labeling a lawnmower question, get the obvious one, gravity. Break your force up into vertical and horizontal components. What if instead of lifting upwards at an angle, 55 degrees, what if I was pushing downwards? What would that do to the normal force? Because this one here would not be pointing up, Roy. Which way would it be pointing? The opposite of up. Begins with letter D, has 4 letters, and ends in an N. Down. And so you would be adding to gravity. The normal force would have to be even bigger. In fact, what does A want me to find, Chris? All right. We're going to write a vertical equation. Is this sinking into the ground like quicksand? Is it lifting into the air like Superman? Then what can you tell me about the vertical forces? Since there's no acceleration, they're in balance. Everything down equals everything. What are my down forces? What are my up forces? Nick, what force do a lot of kids want to put there? 55. It's not. It's the vertical component. By the way, let's go find that vertical component over here, opposite hypotenuse. Right? Which trig function? O and H? Sine, yes? Sine of 65, sorry, 21, I'm thinking the last angle. Sine of 21 equals Fy over 55. Algebraically, Doug, what's Fy? How to get the Fy by itself? So Fy is the same as what times what? Did you say sin? Sin is when you swear in my class. Sin is when you call sign sin. That's a sin. 55 sine 21? Yes? So here's what I'm going to say. I'm not going to bother typing that into my calculator. Just wherever I see an Fy, what will I replace it with when I'm typing? 55 times sine of 21. Oh, boy. Chris, what was A asking me to find?
Normal force?
Which of those three that I've written there is the normal force? Which one of those is the normal force? Fn. How to get the Fn by itself? Ah! Okay, we got the whole package. This is great. The normal force is going to be gravity minus Fy. Where gravity is mg, what's m? More specific, what's m? 7. What's g? Yep. Minus Fy is 55 sine 21. What is the normal force? And this is why, Joel, whenever we said friction is what times what, or whenever I said I don't know the normal force and you said it's mg, I said, well, you have to look at the free body diagram. This time it's not mg. This is what we'll start looking at in Physics 12. We start to say, oh, we don't have to have things in nice straight lines. It makes more some interesting questions. What'd you get? 7 times 9.8 minus 55 sine 21. Anyone? 48.89. 89 what? What comes after that 9? No, what number on your calculator comes after that 9?
It goes 48.889.
Oh, 48.889. So 48.89. Sorry, I misheard you. 48.9 newtons. That's the normal force. Race, what's B asking me to find? Friction is what times what? Mu times the normal force? I don't know the normal force. Oh, but look. I just calculated the normal force indirectly in part A. Right? Friction is going to be mu Fn, which is going to be 0.21 times, hey, if you still have that number on your calculator, use it. Otherwise, I'll use 48.9. But hey, if you got the number on your calculator, be more accurate. Times by 0.21. What's the friction force? 10.27. Anybody else? Yeah? I'll go 10.3, but I'll keep that 10.27 stored on my calculator. By the way, if I lifted up at a higher angle, what would happen to Fy? Bigger, smaller, or stay the same? If I lifted up at a higher angle, what would happen to Fy? Bigger, smaller, or stay the same? Bigger. You're lifting up bigger. Yes? if this gets bigger, what would happen to the normal force? If this number got bigger, what would happen to the normal force? Smaller, what would happen to friction? That's why it's easier to slide something when you lift up. If I'm dumb and I push down, what happens to the normal force? Sorry, what happens to Fy? Gets bigger in the downwards direction. What happens to the normal force? Gets bigger, and since friction is mu times the normal force, it's not going to slide so easy. You knew that, but there's the physics of it. Kelly, what does C want me to find? Ooh. Who's winning? Look carefully at my free body diagram, and don't you dare say 55. That's a slanty angle. We're not going to be using that. Who's winning? Which way is this accelerating, do you think? Stefan went, which is, what do you mean? To the right. Who's winning? What? Fx. Not a force that initially was given to me in the question, but it's a component hidden in that 55, 21 degree angle. Who's losing? So, winner. Isn't this a great review of forces, by the way? Winner minus loser equals, and we said that always equals F net, and F net was ma net. There's your net acceleration. Kelly, how would I get the a by itself, since that's what they're asking me to find? So if I hear you correctly, and I think I do, a equals Fx minus friction divided by m. Oh, problem. I don't know Fx yet. Back to my little free body diagram. You know what? Fx is adjacent. 55 is still hypotenuse. Which trig function can I use to find Fx? Cos. In fact, it's going to be exactly the same as the work that I did for Fy, except wherever you see a sine, what will there be instead? Cos. So I think I'm going to get cos 21 equals Fx over 55. I think Fx equals 55 cos 21. What's Fx? 55 cos 21. What's the acceleration? 55 cos 21 minus, what was friction? 10.3, or if you have that number stored in your calculator more accurately, was it 10.27?
Yeah.
Yeah? I'll go with that. What came after the 7? Did you round off properly?
6.
So shouldn't it be 10.28?
No, it was 10.266.
Okay, so 10.27. Good. All divided by, I've forgotten, what was the mass? 7? Hey. What's the acceleration? By the way, hopefully this is also, you're going, oh yeah, we did this in November. This is a nice November-December review. Little winner minus loser. Little friction, mu times the normal force. This is why I never said friction was mu mg, because it's not always. It was most of the time in Physics 11, but not always. Maddie, what'd you get? 7.72? Anybody else? Yeah? Birthday boy got 7.7 as well? 7.7 meters per second squared. We'll even add a direction like it's a vector to the right. Okay. Now here, Jamie, I walked you through every step. Step A, step B, step C. I would have no big problem in Physics 12 simply giving you the diagram and the information and saying, hey, what's it accelerating at? Or even better yet, saying, if it starts from rest, how far will it get after 30 meters? In which case, you would need to, D, you would need to find A, VI is 0, you could find VF or time or how long or whatever. That's a Physics 12 question. Taking this with a slanty force and then applying it for something.
Mr. Dueck?
Yo.
On the acceleration maximum thing, 5.87.
Oh, is the 7.7 wrong?
Yeah.
Ah. 5.87?
Yeah.
So who got the 7.7s? Did you put brackets around the top because there's more than one number in the top there? Also good review. Yes, birthday boy? Bracket 55 cos 21 minus 10.27. Close bracket divided by 7. Hey, oh, wait a minute. Oh, Dueck. Close your bracket off for the cos. You get 5.87?
Yeah.
.87 meters per second squared to the right. Now it's funny, as soon as Aaron said that, 15 of you were like, yeah, I got the same thing, cowards. Should have spoken up sooner. Turn the page, or next page over. Okay? Example 4, same question, except there's a crucial error. What I did is I did a generic diagram, because these are tough to do, and then I tried to list everything you needed, but I forgot to give you the coefficient of friction, like a complete idiot. I fixed it this morning finally, and we had a laugh because when I opened up this lesson, it said Lesson 3, 2009. So apparently I've been doing this for 4 straight years. But I fixed it, finally. Okay. What does A say? TJ, can you read the instructions for A?
Draw a free-body diagram clearly showing all the forces acting on M1.
It's going to be really, really similar to this one. What does B want me to find, Kelly? Find the horizontal and vertical components. We did it step by step when we needed to, or you could have found them both at the beginning. Because Nick, the key of this lesson, what I'm trying to teach you for the applications is, if they give you something slanty, don't deal with it slanty. Break it up into its components. Way nicer math. Nick, what does C want me to find?
Vertical force equation and horizontal force.
The vertical would be gravity down equals normal force up plus Fy. Horizontal would be Fx minus friction equals Ma. What does D want me to find, Maddie? This is the same question we just did. I'm not going to do it. I did with my block E's, but I think it was overkill. If you want to try it, I can tell you the answer to the acceleration, because if you get the acceleration right, you must have got everything else. So if you want to try this just for practice, the answer to the acceleration was 9.68. Completely up to you. Or if you want to, hey, when you're studying for the test, there's one more question for you to practice. But here's your homework. And you can work on it for about 15 minutes, and I will give you time next class. Next class, you'll also have a take-home quiz. Number 1. A week Thursday. Number 1. What word did I underline here in number 1? Now that's going to be important because instead of Fy pointing up, you're going to have Fy pointing down. I think the normal force is going to get bigger. I'll see if you can figure that one out. I didn't do one like that with you. See if you can figure it out. Number 2, fairly straightforward. That's actually a nice review. Number 3, fairly straightforward. 5 is tricky, but you might be able to figure it out. You're going to have to find, I don't know what that 7 is there, 45 degrees to this horizontal. You know what? Let's fix that in my lesson now too, Mr. Dueck. Apparently you've had that glitch there from 2009. Sheesh. Okay. Dunk. Save. Try number 5. I haven't done one like that, but see if you can figure it out. Skip 6, skip 7. Number 8, what are they asking me to find? Amanda, what's changing anything? Did you say minus? You're going to have to subtract 2 vectors. How do we subtract 2 vectors? We don't. We add the opposite. This is where you use that subtraction trick in Physics 12, is really when you're finding a change in. I'm sticking some Physics 12 in here. And then you can try 9, 10, and 11. I did attach the answers. This is not homework. What is homework? Well, if you have it done, if you want to hand in this sheet here that was called Vector Additions, because this is the one that I assigned pretty much everything. If you got that done, great. If not, get that in next class as well.